Welcome to the Computer World Terminologies and Concepts series. This video explores Ethernet and network cables, which form the physical backbone of wired networking. We'll cover the different types of cables, their standards, how they're installed, and how they're tested. Network cables are the wires that connect computers, routers, switches, and other devices together, allowing them to communicate and share data. Understanding these cables is essential for anyone working with computer networks, whether at home or in a professional environment. The most common type of network cable used today is twisted pair, which consists of 4 pairs of copper wires twisted together. Twisted pair cables are organized into categories based on their performance. Category 5 Enhanced, or Cat5e, supports speeds up to 1 gigabit per second and is still widely used. Category 6, or Cat6, supports 10 gigabit per second speeds, but over shorter distances of up to 55 meters. Category 6, or Cat6, also supports 10 gigabit per second, but over the full 100-meter distance. Finally, Category 8, or Cat8, is the newest standard supporting speeds between 25 to 40 gigabits per second and is used primarily in data centers. Fiber optic cables are a different technology that uses light instead of electrical signals to transmit data. They offer much higher speeds and longer distances than copper cables. There are 2 main types of fiber optic cables. Multimode fiber, or MMF, has a larger core diameter of 50 to 62.5 micrometers and is suitable for shorter distances up to 600 meters. It's less expensive and commonly used in local area networks. Single-mode fiber, or SMF, has a much smaller core of 8 to 10 micrometers and can transmit data over much longer distances of up to 200 kilometers. Single-mode fiber is used for long-haul backbone networks and long-distance telecommunications. Let's compare the twisted pair standards side by side. Category 5, E operates at 100 MHz bandwidth and reaches speeds of 1 gigabit per second over 100 meters, making it suitable for general local area networks. Category 6 operates at 250 MHz and achieves 10 gigabit per second speeds, but only for 55 meters. Category 6 doubles the bandwidth to 500 MHz and maintains 10 gigabit per second speeds over the full 100-meter distance, ideal for data centers. Category 7 reaches 600 MHz bandwidth for 10 gigabit per second enterprise applications. Category 8 is the latest standard, operating at 2000 MHz, supporting 25 to 40 gigabit per second speeds, but with a maximum distance of only 30 meters. Higher category cables are faster, but require shorter distances or specialized installation. Fiber optic cables are classified into different optical modes designated by specific standards. Optical Mode 1, or OM1, uses a 62.5 micrometer core, is identified by an orange jacket, and supports 1 gigabit per second speeds over 275 meters. Optical Mode 2, or OM2, has a smaller 50 micrometer core, is also orange, and reaches 1 gigabit per second over 550 meters. Optical Mode 3, or OM3, uses a 50 micrometer core with an aqua-colored jacket, supports 10 gigabit per second over 300 meters, and is commonly used in modern data centers. Optical Mode 4, or OM4, also has 50 micrometers, aqua jacket, and maintains 10 gigabit per second speed over 550 meters. Finally, OS1 and OS2 are single-mode standards with 8 to 10 micrometer cores, yellow jackets, and support speeds up to 100 gigabit per second over distances exceeding 200 kilometers for long-haul backbone networks. There are 3 primary methods for installing network cables. Underground installation uses either conduit or direct burial techniques, burying cables 1 to 2 meters deep, providing excellent protection and ideal for long-distance runs. Aerial installation uses utility poles or catenary wire systems and is faster to deploy, commonly seen in urban areas, though cables are exposed to environmental conditions. Blowing installation, also called jetting, uses air pressure to push fiber optic cables through existing ducts at speeds of up to 1,000 meters per run, making it extremely efficient for long and complex routes through buildings and streets. Each method has trade-offs between cost, installation time, protection level, and suitability for different environments. Proper cable testing ensures network reliability. Continuity testing verifies that the complete electrical circuit exists from one end to the other and detects any opens or shorts in the wiring. Wiremap verification confirms that each pin is connected according to the T568A or T568B standard wiring patterns, identifying crossed or reversed pairs. Attenuation testing measures signal loss across distance and frequency, ensuring signal strength remains within acceptable decibel thresholds. Crosstalk analysis measures both near-end and far-end crosstalk to identify interference between wire pairs. For fiber optic cables, optical time domain reflectometry, or OTDR, uses laser pulses to map the fiber path and detect breaks or issues. Return loss checking detects impedance mismatches from poor terminations or physical damage to the cable. Proper maintenance ensures cable longevity and performance. Regular visual inspections and cleaning are critical since dust is the #1 cause of connection failures. Clean connectors before each use with lint-free materials only. Respect bend radius limits. Copper cables should not bend tighter than 8 times their diameter, while fiber optic cables require 10 to 20 times their diameter. Never exceed the manufacturer's maximum pulling tension when installing cables, and use compatible lubricants for longer runs. Monitor environmental conditions including temperature fluctuations, humidity levels, and UV exposure, as these affect cable performance. Maintain comprehensive documentation, including as-built records, OTDR measurements, and clear labeling for future maintenance. Finally, follow proper safety procedures. Never look into fiber optic connections without confirming laser status is off. Always use infrared safety glasses when required, and obtain proper training before handling sensitive fiber optics.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.